favorite reliability and test guy, and I'm here with another fun-filled video. This current video is on environmental test equipment. I hope you enjoy this video, and if you do, don't forget to hit that like button and subscribe to my channel. Okay, let's get started. In this video, I will perform an introduction to environmental test equipment. Again, my name is Tom Resch, and if you like this video, don't forget to hit that like button and subscribe to my channel. And if you don't, go ahead and go back to your cat videos and your blooper videos while the rest of us learn about the really cool field of reliability and validation testing. Thank you for your support. In this video, we will discuss definitions. What is a temperature test chamber? What is a temperature humidity chamber? What is a altitude chamber? What is a vibration and shock test system? What are the different types of ingress protection test equipment? What are the types of corrosion and agent test equipment? And what is combined environment test equipment? Below is a high-level summary that captures the process from requirements to test reporting and test results. In this video, we will cover the test execution step, or a subset of the test execution step, test equipment. Let's go ahead and define environmental testing. What is environmental testing? Environmental testing, not to be confused with testing for air, water, and land contamination, is a branch of the reliability and validation and test engineering fields that simulates the harsh environments and stresses that a product or system will endure while in use by the end customer. However, environmental testing can simulate the handling, storage, and shipping environments of a product or system as it travels to a retailer or an end user or a storage facility. Some types of environmental tests include climatic testing, which includes weather conditions and sunlight exposure, gases, salts, and other types of natural and man-made environmental stresses and elements. The second type of environmental test is dynamic testing, which includes field and shipping vibration, shock, drop, and compression and tension loads and stresses. You will often hear me break up dynamic or mechanical testing into a separate category from environmental testing, even though these mechanical or dynamic tests are often classified under environmental testing. The reason for this is that some vibrations are generated internally by the product or system itself, such as with engines, motors, and other moving subsystems that generate vibratory motion internally within the system or product itself. However, a washboard road surface that a vehicle would travel over after a rainstorm or air turbulence that an aircraft would encounter would technically fall under environmental stresses or excitations. Another type is EMI, or electromagnetic interference testing, which is also a type of environmental testing, as it tests for susceptibility of electronics to electromagnetic interference in the radio frequency spectrum. In this video, we will cover the fundamental test equipment for climatic and dynamic tests, as EMI testing and test equipment require their own independent video and discussions. If you would like to see me do a video on EMI testing and EMI test equipment, please let me know in the comments below. Additionally, the examples of test equipment in the following slides may not represent the exact equipment you need for your product, and there may be, as they say, different ways to skin a cat, so if you need help selecting equipment for a specific requirement or product, feel free to comment below or reach out to me in the links in the description section. What is a temperature test chamber? A temperature test chamber simulates real-world temperature extremes, or in some cases, temperature extremes that are out of this world, as in with space vehicle or satellite testing. There are many different types of temperature tests that can be performed using both mechanical or liquid gas cooling and heating systems. As at the bottom left-hand side of the screen, you can see an example of a reach-in temperature test chamber. What is meant by reach-in is that you literally reach into the chamber to place or install and remove your product from the temperature test chamber. Another variation of a temperature test chamber is a walk-in chamber, which is once again a literal term that you can actually walk into the chamber to install or remove your product or system. So think of a reach-in as a refrigerator you have in your house when you go to grab a beer or ingredients to make a sandwich. And a walk-in chamber would be parallel to going to the walk-in fridge at a Costco or Sam's to grab your milk or produce. Here are two types of temperature tests. The first graph demonstrates a constant temperature test, which can simulate a storage test or high temperature performance test. The second example is a temperature cycling test, which simulates the expansion and contraction stresses that occur throughout the day as the ambient air temperatures heat and cool. You can get different results by varying your ramp rate. Remember, faster rates mean faster thermal stress accumulation, which branches out into future video topics that we will discuss in accelerated testing. So stay tuned to my channel for that video. A quick note, with temperature tests, you will often hear terms such as operational or non-operational temperature tests. What is meant by this is that the temperature profile is either ran with the product or system in operating conditions, or with the product powered off. For example, a mission temperature profile would have your system or product operating as if it were being used by a customer under temperature extremes. If you're running a storage temperature test, the system or product would be powered off and in a non-operational state, as it would be as in a storage in a warehouse or customer location until it is used. What is a temperature humidity chamber? A temperature humidity chamber simulates both humid, which is humidification, and arid climates, which is dehumidification. As you can see, the chamber in the bottom left-hand part of the screen is very similar in the outward appearance to a temperature test chamber. The key difference are the components that are included internally in a temperature humidity chamber, which will have options such as a steam generator for humidification and a dehumidification coil, think small evaporator coil circuit, for low humidity conditions. In fact, many different temperature test chamber manufacturers offer a humidification and dehumidification option for their temperature chambers. So be sure to ask about these options when getting quotes for temperature test chambers from a chamber OEM, if you are interested in including a humidity option or dehumidification option. I have a wealth of experience and knowledge working on the internal components of a temperature and humidity chambers, and can go into much deeper technical discussion on the inner workings and troubleshooting of these systems. If you would like to see me create a video on the technical operation of a temperature test or temperature humidity chamber, feel free to ask in the comments below. Here are two examples of temperature humidity tests. The first is temperature cycling with a constant humidity rate, and the second is constant temperature and constant humidity. There are pitfalls to look out for with temperature cycling and a constant humidity, which we will cover in a later video specifically dedicated to temperature humidity testing. Remember that higher temperatures and humidity levels produce faster aging and degradation of materials. We will also discuss the benefits of humidity and diurnal cycles and their impact on verifying and validating sealed cavities and enclosures in future temperature humidity test videos. What is an altitude chamber? An altitude chamber simulates altitude conditions encountered on mountaintops, aircraft, and even space vehicles. On the bottom left-hand side of the screen is an example of an altitude chamber. Notice the appearance is very similar to a temperature or humidity chamber. However, the view and window materials and structure and the chamber's internal cavity are made with thicker, more rigid materials to withstand in vacuum environments and prevent implosion. The level of altitude simulated depends on the vacuum system used for the chamber. Rough vacuums will simulate lower vacuum levels. Higher aircraft altitudes require a medium vacuum using a combination of a rough and then a 4-line vacuum stage pump. And to simulate space environments, it requires a high vacuum environment using a turbo or cryo pump to expel the remaining gas molecules from the test chamber. Again, the size and materials used to construct an altitude chamber vary depending on your test and can range from an aircraft simulation similar to a chamber in the slide, or a large stainless steel vacuum cylinder, or even a walk-in vacuum cylinder for space vehicles and satellite testing. We will go into more detail on this in a later video on altitude testing. A couple of examples of this altitude testing are an ascent and altitude hold, which simulates an aircraft taking off and maintaining an altitude height for the flight path, or an extreme example in the other test example of rapid decompression event when an aircraft rapidly loses altitude, such as in a nosedive condition. One failure mode example that is tested for with altitude testing is the corona effect. No, I am not talking about the corona that you just grabbed out of your reach-in refrigerator. I'm referring to the discharge phenomenon that occurs when two separate circuits have an arcing event that occurs in the absence of air between the two circuits. Now let's talk about one of the cornerstones of the dynamic testing world, the vibration and shock test system. Whoa! In the picture to the left is an example of an electrodynamic shaker that it has a similar theory of operation to a giant loudspeaker. You can watch my videos that are currently out on vibration test theory and application, both parts 1 and parts 2. To learn more about electrodynamic shakers and their application. There is a multitude of different types of vibration test systems that use various methods to generate vibration and shock excitation, and each has its own special use case, including hydraulic, pneumatic, drop shock towers, and impact shock systems. If you would like me to cover non-electrodynamic shaker systems, their technical operation, and more details on their applications, comment below and let me know. Now, if you are fortunate enough to talk to some of the old-timers in the dynamic test world, they will tell you about a time when a vibe controller for a vibration test system was a giant rack and that you could only produce sine frequencies by manually tuning the knobs on signal generators up and down to produce sine sweeps or perform a sine frequency dwell. These same old-timers also had to walk through 10 miles of snow to get to school and use slide rules to solve advanced calculus problems. Fortunately, we live in the modern era that has computers and signal processing, and we are able to create a multitude of different vibration and shock signals, including random, sine on random, and random on random. For shock, we can perform classical shock pulses such as half sine, terminal peak sawtooth, and trapezoidal, and we can also perform shock response spectrum or SRS and time replication shock. Now keep in mind, many vibration controllers today also offer time or field replication of vibration mission profiles as well, which takes collected data from a customer or test system out in the field and produces a vibration profile that you can replicate on your vibration test system. I discussed the 4 types of vibration tests listed above in my 2-part series on vibration theory and application, which is currently out on my channel now. And I will cover shock in more detail in a later video. So what is ingress protection? And what does the equipment look like for different types of ingress protection tests? You have probably purchased products with marketing lingo such as IPX7 rated or IP67 rated and so forth. or worked at a company that calls out ingress protection specs. We will go into detail about ingress protection testing in a later video, but for now, the IP ratings indicate either a resistance rating to intrusion of foreign debris, such as dust, or from water or moisture. Some examples include a rain chamber, which, as the name implies, tests products to determine their resistance or protection against rainfall. Dust chambers, which use a variety of mediums such as Arizona road dust or talcum powder to simulate dusty roads, dust storms, and settling dust in a very dusty environment over a long period of time. Now, I gotta just take a minute here before we talk about immersion testing to just say, wow, look at this immersion tank. This is just impressive. I've never seen anything like this. I think the opposite happened in this company. As you've heard the saying, shoot the engineers and go into production. I think the engineers shot the business unit on this one when this was designed. I've worked at multi-billion-dollar companies that didn't have anything this impressive before. I'm just absolutely amazed. Most companies will use big plastic or metal basins and cylinders to perform their immersion tests, but this one really makes for a great presentation example, which is why I pulled it out of Google and showed it to you guys. So enjoy it in all of its glory. Now, I'm not going to say don't buy this chamber. I mean, if you really want to have an impressive state-of-the-art test lab with equipment that nobody has ever seen before, go ahead and get this piece of equipment if money is not an option for you or not an issue for you. This tank in this example allows for testing to IPX7 or up to 1 meter of immersion in water. There are variations that include immersion in salt water, which can wreak all kinds of havoc on your product. So keep that in mind if you are designing a product that has the possibility of getting dunked in or splashed with salt water. Another example of ingress protection test chambers is a spray chamber, which simulates your IPX up to your IPX6 type ratings. Again, there is a multitude of different types of spray chambers and spray booths, and the pinnacle of ingress water protection is the IP9K test, which is tested for with a steam high pressure water system. So kudos to you if your product sealant can hold up to that test. That's a very impressive product, and you've put a lot of work into the design, so good work there. So let's talk about corrosion testing. You know that lawn chair you have outside or charcoal grill that has turned into a rust bucket? Thank your good friend Mr. Salt or Mrs. Oxidation for that mess. Also remember that beach ball you left outside that's now bleached out and cracking? The sun reminded you not to leave your stuff outside with that little gem. So keep your neighbors happy and keep yourself happy by keeping your stuff inside and out of the sun. Some examples of corrosion and agent test equipment include the salt fog or salt spray chambers that can produce corrosion environments such as the fog off of an ocean or severe corrosion that happens when you drive your car down an icy road that was melted away and is by using road salt compositions. The next example is a mixed flow gas chamber, which simulates corrosion that occurs when products, especially exposed electrical contacts, encounter a mixture of air pollutants over a period of time. You will know exactly what I'm talking about here if you live in a city with a lot of industrial work and combustible byproducts getting dumped into the air. A UV chamber or ultraviolet chamber simulates exposure to sunlight and is used to accelerate aging of materials from UV light. You would be amazed at how difficult it is to not have fading or bleaching and or cracking occur with certain colors and materials. So keep that in mind and test early when you are looking to select cosmetic or even critical parts such as seals that will be directly exposed to ultraviolet light. Last but not least, let's talk about combined environment test equipment. There are other variations, but three major types of test equipment I would like to highlight for this video are The vibration over temperature chamber, which exposes a product or system to simultaneous temperature and mechanical stresses. A couple of examples of this in the real world are automotive and aerospace vehicles and systems, which are exposed to both temperature and mechanical loads simultaneously. Temperature, altitude, and humidity chambers is another type of combined environment system. Temperature, altitude, and humidity testing has real-world applications and is also called out as a test in the 810 mil standards. These tests can get really tricky, and I have to dedicate a separate video on altitude, temperature, humidity testing if you are interested. So comment below and I will make it so. For the final example, another combined environment test is the UV humidity chamber. Want a real-world case of this example? I've got one word for you: Florida, where you have all the humidity and sunshine you could ever ask for. I can speak firsthand on this as I was born and raised as a former Floridian. The combinations of UV and humidity can really give your product or materials a hard time. We can discuss this in more detail in a later video. Just leave a comment if you want me to dedicate a video to UV and humidity testing. Let's discuss key takeaways from this video. But before we do, I just want to say one thing. This channel is a democracy, and I mentioned a few times that I will create videos if you leave a comment. So the more comments I have for a specific topic, those topics will become the priority for discussions in my future videos. So make your voices heard and comment below. So things you can take away from this video are: decide if you want to invest in test equipment for your company or utilize third-party labs. Make sure to select equipment that can perform your test profile or profiles. Make sure you account for the required facilities and building power requirements for the test equipment that you actually purchase. If you need help selecting your test equipment or planning for your test lab, I can help and have a track record and background designing and building test labs. So feel free to reach out to me in any of the links below to see how I can help. Hey guys, thank you for watching this video. I hope you enjoyed it. If you have any questions or comments, feel free to reach out to me at one of the links below. Thanks again for watching.